bonjour, as we say in French. I will have a moment of great pleasure, fun, because I will have a conversation with a very old friend. We know each other since more than 20 years. He is an incredible operator, and please welcome very warmly Nikesh, our Chairman and CEO of Palo Alto Networks. Nikesh, my friend, it's good to have you. I think that the first time we met, it must be 2005 or 2006, something like that.
2005.
2005.
I was learning how to sell ads from you, and you told me this online stuff, it's okay.
And we made an agreement, the first of the kind.
That's right.
And
your office right by the Champs-Élysées?
Yes, it's still there. We have no change, which is not the case. You have done an incredible job with Google by transforming the ad business. And if Google has been able to capture such a large share of business, you have a very important responsibility. And fantastic, so congratulations. It's really one of the most important building piece of Google Alphabet. And after one or two tries, you are...
Oh, I used to work with Josiah. He was at Alibaba, I was at SoftBank.
Yeah.
He did better than me there. Yeah.
You were with SoftBank, and you have had a formidable, unique impact on shaping the very future of Palo Alto Networks. So I'm not sure that people know everything, but to start, I would say that your career at Google was nothing short of legendary, honestly. You have not only transformed and built the business, but you have fundamentally transformed the advertising landscape. Because if agencies today work as they do, and if clients are buying space as they do, you have your share of responsibility. So, what is interesting to understand is the catalyst. What is driving you? How you are inspired for the transformation? So maybe you can take us a little bit in your journey and explain to us how you have been able to do such a fantastic job.
Well, thank you, Maurice, and big round of applause for the legendary Mr. Maurice Libby. So, Maurice, I put it down to natural curiosity. I am forever curious. And I work in reverse order. For the last few weeks, I'm paranoid that I'm getting old. And I've been spending my time with, who are effectively kids, 25 to 27 years old, who are running these new AI companies. I went last night for dinner for 2 hours with the CEO of Perplexity. I was with the CEO of Codium 2 days before that. He's 26 years old, and he's explaining to me how the whole world is going to fundamentally change. And I'm sitting there paranoid saying, yes, he's right. This world is going to fundamentally change. So if you track backwards, 7 years ago, I went to cybersecurity and said, wow, everything that is connected will stay connected, and everything that is not connected will get connected. And if everything is connected, there are 10 billion artifacts connected to the internet. In our industry now, in cybersecurity, we call it expands the attack surface. So now you can attack things in so many different ways. So I've always sort of gravitated towards growth industries. I don't know how to do non-growth industries, and that's the same case at Google. And I started, we were a $2 billion revenue company, and Europe was about $800 million. And I remember the ad market was $700 billion. I think Google revenues are close to $300+ billion in advertising now. So you can see that from 2 to 300 is not a bad progression. I think similarly, we're likely to see that in cyber. And clearly AI is going to change everything that we know anyway.
What is interesting is that you are moving from something which was already quite sophisticated, interesting, and even fascinating, which was Google, to a world which is much more technical, much more scientific, much more complex. When you speak about cybersecurity, a lot of people don't understand what you are talking about.
I'm still trying to figure it out.
So you don't either.
I kind of do.
So how have you been able to make such a jump from something you grew up into it, you understand it inside out, to a new territory which is highly sophisticated?
So for the first 1 year, I used to meet about 15 cybersecurity startups a week. And every morning on my way to work, I would call our chief product officer and ask him all the stupid questions. And every evening on the way back home, I would call our founder. So I would bookend it for an hour every morning, hour every evening, discussing the evolution of all the different things. And eventually, I developed a perspective, and I think that's kind of helped us out, which is the same thing I'm trying to do with AI. Because I think AI is going to change everything we know and make it very, very different.
We can expect that AI will transform society.
Yes.
And the AI will transform all the jobs, the way we operate. AI will have also an impact in everything we do.
Yes.
Today, Palo Alto Networks is solving a lot of issues. Can you tell us what is your vision, coming from where you come and knowing almost everything in our industry of the future of cybersecurity with AI inside it?
So let's talk about AI for a few minutes, and then we'll switch it to how cybersecurity works. I remember when I met you in 2005, when I was at Google, it was still not very well known. And I think the biggest impact things like Google search and technology have had, it's called democratization of information. Everybody has access to roughly the same amount of information or same kind of information. You don't have to be rich. You don't have to live in a capital city to get the news. You get the news as it happens on your phones and how you want it. And that's amazing. That allows us to be much better at many things.
I interrupt you for 1 second because you are prompting, like in AI, something. When we made the strategic agreement between Google and Publicis, our executive committee was divided.
Yes.
And there were the people who were telling me, Maurice, you are wrong. We should not go with Google. We should go with Yahoo.
Yes.
So,
so you made the right decision.
No, this means that at that time, it was bad.
Yes. Yes, it was.
It was bad, and this can be the case for almost everything in the digital world.
I agree.
Because Yahoo was there, Google was growing, but a lot of people, including Microsoft, you remember, they wanted to buy Yahoo at that time, were believing that they will be the winner. So it's incredible what you have done out of what was a nascent company.
And I think the movie is going to play itself out in AI. So if you think about, we talked about democratization of information. I think AI has the ability to democratize intelligence. Because we will all walk around with roughly the same amount of intelligence in our pocket. Which means we will know how to solve known problems. AI is fast moving to a place where every known problem will be figured out, and your mobile phone or your computer will be able to actually tell you how this problem was solved. Now, the biggest fear or the biggest opportunity is when AI becomes super intelligence, where it starts to solve unknown problems. It will find cure for cancer. It will find a cure for many maladies. It will find better solutions than human beings can. But imagine the world when you're democratizing intelligence. Everybody's equally intelligent as a starting point. And then the question becomes, what do you do with that base level of intelligence? That's going to change the creative industries, because now we're equally as creative. Now we have to find something with that base knowledge to be uber creative, no pun intended. And similarly, in cybersecurity, we have the same challenge. We have to figure out how to not just be as good as the attacker, but how to be better than any attacker in the world.
So you mean that AI will have to be superior to any AI of the attacker?
We will have, yes, and we will, as human beings.
You will have to think further than any of the possible attacker.
That's right. Similarly, in creative worlds, every one of us can have a device which Google's new VO3 and new creative capabilities. Every person with a computer will have the ability to design creative advertising, perhaps, equally well. Now the question is, what do I do with that base level of knowledge? How do I beat everybody around me? And what does the superior skill look like?
So, building on that, finally, AI is a little bit like Janus.
Is it like jazz?
Janus. Janus is the ancient Roman goddess which had two faces.
Yes.
One good and one bad.
Yes.
So that is AI.
Yes.
Because with AI, there is a lot of things which are positive, which can happen, and there are a lot of things which are either uncertain or frightening or worrying for the people. When it comes to cybersecurity, it is also both.
No, we only have one objective: to make the bad face go away.
Okay.
We're staying on the good side, yes.
Okay.
But I mean, just expanding on what you just said from an AI perspective, you're right, because on one hand, if we train something how to find the cure for cancer, the same model can be used to create a bioweapon. So our job becomes, how do we make sure that AI is not used to build the bioweapon, instead is used to cure cancer? Or the same AI which we are using today, we call it the brain. I don't know, I haven't seen a driverless car in Paris. Is there a driverless car in Paris?
Yeah.
There is. Okay, so I call that giving AI agency, giving AI arms and legs. When you start letting a brain decide how to drive, when to stop, when to turn, you just give it AI arms and legs. And in the next 5 years, you will see a lot of things will be given arms and legs around us, which will be managed by AI. Then again, as a bad actor, the question is, can I take over that model and make it do things? Imagine you sit in your driverless car and it doesn't stop, just keeps driving away with you. It's a lot easier.
When you have an e-commerce company like our friend Joe Tsai,
Yes.
Alibaba, if they are making a mistake or they are missing a new innovation, they do some harm to the business, but at the next edition, the next version, they can catch up, it's okay. When it comes to cybersecurity, you have not that luxury.
No.
You have to be right all the time, and you cannot be late on any innovation. So tell me how you are organized and what kind of investment, people, etc. you are investing in order to stay current.
So Maurice, when I started 7 years ago, we were about an $18 billion company, and we used to be one product swim lane. And I remember Larry Page had told me that in tech, if your product is bad, you will die. Which is the example he gave of Yahoo or the Sun Microsystems example. It is quite prevalent in the tech industry. Our tech was good, but I looked around me and every year 2,000 cybersecurity companies get funded in the world. I said, one of these guys is going to figure out something we don't know and we'll be extinct. So in the last 7.5 years, we have bought 20 companies We have doubled our R&D spend in terms of number of people. We, if we are not smart enough to build it, we're humble enough to buy it. So we are constantly trying to stay at the bleeding edge of innovation. We always buy number one or number two in the market because we believe they have the best technology and therefore we must have it. So we have turned what was an $18 billion company now to a $130 billion company by spending about $5 billion in the last 7 years and making sure, I was seeing this morning, we have hit the 97th Fortune 100 company that uses our products. So we made sure that our product portfolio is amazing. I've also made sure that most of the large customers in the world have Palo Alto inside.
With AI, one of the biggest threats is fake.
Yes.
Fake voices, fake face, fake messages. So you are a good CEO, a good CFO. You receive a fake message from your CEO, his face, his message, his voice, and it says, okay, wire to my friend Nikesh $20 million.
That's a good voice. Really.
Yeah, exactly. I thought that you will improve it.
Yes.
That's the reason. So, how do you deal with that?
I think it's going to be fascinating. Return to the office. We'll be back sitting across from each other to make sure we can do it in real time. But I think on a more serious note, I think that is the biggest risk with AI, with the ability to create this ability where you can have fake phone calls or fake videos and fake messages. There are a series of techniques being utilized right now around watermarking and making sure that when you create a tool that creates these fake videos, that the tool will actually advertise that I'm a tool that can be used to make fake videos, so you can be more aware. But it just as is the case with every technology, and we call it Janus, it has a good side and a bad side. I think that is the bad side we'll have to protect against and make sure that we have enough safeguards in place to avoid that from happening.
So this means that one of the risks for society that we see tomorrow a fake message from Zelensky or a fake message from a scientist inviting people to do something, etc. Is Palo Alto Networks a solution to de-risk the society, or is it something which is a lost cause and we have to educate the people and live with that kind of issues for the future?
So we have tools that we can make available. I think the opportunity there is going to belong to more like the Googles and the Facebooks and the Apples of the world, because they are the mass distribution players in the market.
Exactly.
They will have to produce capability or introduce capability without
But you
tools.
can sell them.
We're trying.
Yeah, because
We're trying.
you are quite a good
Do you
salesman.
know anybody?
If I remember well, you are a pretty good salesman. So you
Learning from the best.
yeah. So you can sell, you can develop and sell products,
Yes,
because that is one of the most frightening issue of our society, the development of all those fake things which can really kill the trust in society.
Yeah, and I think, as I said, we are going to have to work with the mass providers of social media and other distribution platforms to make sure we can do that.
Nikesh, you have worked in Europe. You know Europe inside out. You have even, I remember, created an event in Sicilia.
Yes. Thanks to you.
Which is still existing.
Yes.
And when you look at the old continent, unfortunately till now we have not been able to create one large company in the field of internet. The largest we have in Europe is SAP and
ASML, you have SAP, you have Philips, but they're all very somewhat old world perhaps.
Yeah. And what would be the recommendation that you would put to President Macron or to Ursula von der Leyen in order that we, if not catch up, at least we have some very strong capabilities and a kind of sovereign AI ecosystem in Europe. Otherwise, we'll be just subservient to the US and to China.
I think we had an opportunity with cloud, which was a missed opportunity, because I know that a lot of work has gone in trying to create sovereign, cloud data centers with partnerships with many of the US companies. I think it's a fallacy to think about these large tech companies as US companies only, because they actually operate in almost every part of the world and deliver services from every part of the world. I know Jensen is going to be here anytime soon. I think we should encourage some version of sort of reignition of AI capability in every part of Europe, in combination with people like NVIDIA or people like Microsoft or people like Google, and say, listen, make us a first-party citizen. Start your innovation here, make sure that European innovation is headquartered here. Because right now, I think the biggest moat is capital. If you think about Microsoft's going to spend $80 billion this year building AI data centers. As the UK this morning, they have announced £1 billion. I don't think £1 billion quite competes with $80 billion with one company. If you add the total amount of money being spent by tech companies, is $300 billion this year, in the next 12 months, in building AI capability. More than likely that is...
But if that is true, this means that the battle is lost.
I don't think so. I don't think that battle is lost to the extent where if you can encourage those companies to divert some of that spending to building European AI data centers and European AI capability, the battle is not lost, because that's not money that's been fully spent. But I think part of that requires the right regulation, the right access to energy, the right sort of acceptance of risk-taking, and that's not easy to do overnight.
Risk-taking, this is something which is not in the European dictionary. Maybe we should include it. Nikesh, I would like to thank you very warmly. We will have, in a few minutes, President of the Republic will be arriving, and I will have to go to welcome him. And later on, I will be back with Jensen Hahn and Arthur Mensch. We will discuss about the agreement that they concluded recently, and they will be announcing the detail of this agreement. And then we will be joined by President Macron, and we will have a further conversation with some interesting startups, French startups, which means that we still believe that startups can scale up, and we still believe that Europe can fight at least in a segment. I would like to thank you very, very warmly. Thank you for making the trip. I know it was not easy. A round of applause for my friend Nikesh. Thank you. Thank you so much. Thank you. Thank you.
AI is a technological challenge as well as a scientific challenge, because we don't know how to build truly intelligent systems yet. It's one of the big scientific questions of our time: what's the universe made of? What is life all about? How does the brain work? Or what is intelligence really? Hi everyone, my name is Yann LeCun. I'm the chief AI scientist at Meta. As humans, we think that language is very important for intelligence. But in fact, it's not the case. Imagine a cube floating in the air in front of you, and imagine rotating that cube at 90 degrees. You can sort of picture this in your mind, and this has nothing to do with language. Humans and animals navigate the world by building mental models of reality. What if AI could develop this kind of common sense, an ability to make predictions of what's going to happen in some sort of abstract representation space? We call this concept a world model. Allowing machines to understand the physical world is very different from allowing to understand language. A world model is like an abstract digital twin of reality that an AI can reference to understand the world and predict consequences of its action, and therefore it will be able to plan a course of action to accomplish a given task. It does not need millions of trials to learn something new because the world model provides a fundamental understanding of how the world works. The impact of AI that can reason and plan using world models would be vast. Imagine assistive technology that helps people with visual impairment. AI agents in mixed reality could provide guidance through complex tasks, making education more personalized. Imagine an AI coding agent that can actually understand how a new line of code will change the state of the variable of the program, the effect on the external world in the context of existing code. And of course, world models are essential for autonomous systems like self-driving cars and robots. In fact, we believe world models will usher a new era for robotics, enabling real-world AI agents to help with chores and physical tasks without needing astronomical amounts of robotic training data. This is a very exciting time for AI research and a captivating set of scientific questions in front of us. We want to understand intelligence itself, as well as learning, reasoning, understanding the physical world, so we can build systems that can help billions in their daily lives. We're excited to announce the release of V-JEPA version 2, the next step in this journey. Stay with us as we continue exploring the possibilities of world models and push the boundaries of AI research.
I'm the AI correspondent at the Financial Times. I'm delighted to be joined by Yann LeCun, Chief AI Scientist at Meta and Professor at NYU. Now, Yann, every time I see you, you are out there launching some new AI model that is changing the way we think about AI. And this year is V-JEPA 2. So, what is V-JEPA 2 and why is it a big deal?
Well, there's a V-JEPA V2 because there was a V-JEPA V1 a while back. Basically, it's a model that attempts to advance along at least three dimensions, three challenges of AI. The first one being AI systems that understand the physical world. The second one, systems that are capable of reasoning. And the third one, capable of planning. So those are three major obstacles or challenges that we need to kind of overcome to have AI systems that go to the next level. And so V-JEPA is one of the first systems that can really learn how the physical world behaves by being trained to predict videos, essentially, right? So show it a piece of a video and corrupt that video in some way. You can mask a piece of it, or just mask the future, the second part of the video, or just a whole chunk of it. And then train a system to fill in the blanks, basically predict what is missing in the video. Now, we've been trying to do this for many years. In fact, this idea of, this is a particular instance of self-supervised learning, and that's really what has powered the success of large language models. And we've been trying to work on this for video for 10 years, actually even more. But, and it's been a bit of a failure until recently. And the reason is that although it's easy to kind of predict the words that are going to follow a particular text, which is why LLMs are working so well, you can't do this with video. If you train a system, you show it a piece of video and you ask it to predict what comes next, there is no way you can predict all the details at the pixel level of what goes on in this video. And so the JEPA idea, that means Joint Embedding Predictive Architecture, and the V stands for video, basically does not even attempt to reconstruct pixels. It attempts to learn a representation, an abstract representation of the video, where a lot of the details are eliminated, so that the system can make predictions in that representation space. That's the basic idea of JEPA. And then we've been trying to apply this, sort of finding recipes to train those things, at the large scale and apply this to sort of various domains, not just video, but just about everything.
And the new thing is also you're using robotics data, so physical collections of physical data collected from how you animate work in a 3D world, right? So tell me, why is that significant?
Well, so that addresses the second challenge, machines that are capable of planning. So once the system has been trained just by watching video to basically predict what's missing in the video at the representation level, there's a second phase where you train what's called a world model. So a world model is something that tells you, given the state of the world at a particular time, that you can observe from a short clip of video, and given an action that you imagine a robot taking, could the system predict what the state of the world is going to be after the action has been taken? And so if you have this kind of world model, you can, the system that has this model of the world can imagine the consequence of a sequence of actions, and therefore can figure out a particular sequence of actions that will fulfill a goal, that will accomplish a task. That's planning. So that's one of the big challenges that AI systems should be able to do. And planning and reasoning are really the same thing, so this could give us a blueprint also for systems that are capable of reasoning. And what we've shown with V-JEPA v2 is that when we train such a world model, we can use it to basically plan the motions of a robot arm to grab an object or open a door or something of that type. Those are not particularly complicated tasks, but what's interesting about it is that the system can basically learn or can accomplish those tasks without being explicitly trained to do those tasks. It's just using its world model to predict what the consequences of its actions are going to be.
And what are the real-world use cases for this? Like, why do we need to build this, and how can we use it?
So everybody is talking about AI systems that can reason, AI systems that can plan, agentic systems that can take actions. To be able to take an action or a sequence of actions reliably, you have to imagine, be able to imagine what the result of those actions is going to be. If you take an action, a sequence of actions blindly and you don't know what the effect is going to be, you're going to make some mistakes. And so current systems, LLMs, don't have those internal world models. They're basically planning blindly by just kind of pretty much regurgitating plans they've been trained to do or produce. If you have this concept of world model, and a lot of people in AI are working on this at the moment, then the system can just project, imagine, what sequence of actions, what is going to be the effect of the sequence of actions, and then plan to accomplish a particular goal. Now, there's still a lot of challenges there on the way. It's not like we've solved the problem. And this approach also connects with some classical work in robotics, in motion planning. The difference here being that those world models are trained from data, and it's completely unsupervised. There is no labeled data or nothing like that.
Now, for AI scientists, one of the biggest goals is understanding machine intelligence, or creating it. This concept called artificial general intelligence, AGI. How does this get us to that?
Well, so I think to get to, so I don't like the phrase AGI, okay, because it's used to designate systems that have sort of human-level intelligence, if you want. And so that relies on the assumption that human intelligence is general. And I'm sorry to say, human intelligence is not general at all. We're very specialized. Slightly more general than most animals, but some animals are smarter than us in certain areas, and certainly computers can solve certain tasks much better than we can. So that means in some way we are specialized, right? So I prefer these two phrases that we use at Meta. One is ASI. It's a little scary. It means artificial superintelligence. It means, okay, by the time that we get to human-level intelligence, we can get past. And in fact, we already have a number of tasks where machines are already superior to humans. So that's what we should be talking about. And superintelligence doesn't mean it's general. It just means it's slightly better than humans in most domains. And then there's a second phrase that we use, and it's AMI. We actually pronounce it the French way, ami, which means friend. And that's basically our blueprint or plan to reach ASI. So there's a long-term plan in the company to basically produce AI assistants that are as smart as humans or perhaps better, that will help us in our daily lives. it's a challenge that we set for ourselves 10 years ago, and now, but it was really sort of exploratory research at the time, and now it's become more of a kind of a product strategy, if you want, even though we don't know how to do it yet. We're kind of starting to see the end of the tunnel, so it's becoming real. And so the AMI plan is a set of techniques that some of us have been working on to basically overcome those 4 challenges I was talking about. Systems that understand the physical world, have common sense, if you want, have persistent memory, can reason, can plan, and also a 5th one, which is systems that are controllable and safe. So basically you give them a task and they accomplish that task, and that's it. They don't do anything else.
Great, I'm glad you mentioned superintelligence, because this week there's been a lot of reports about Meta looking to start up a new superintelligence AI unit led by Scale's Alexander Wang. What's the plan there?
Well, I can't comment on electronic or whatever. This is being discussed, whatever. But what I can say is that the plan of FAIR, Fundamental AI Research, which is the sort of long-term research branch of Meta in AI, has always been to reach human intelligence and go beyond it. It's always been the plan when it was created 11.5 years ago. It's just that now we have kind of a clearer vision for how to accomplish this, and V-JEPA V2 is kind of a step in that direction, if you want. And so it's becoming so real now that it's kind of the ambition of the company to really kind of do this at a product level as well. So Mark Zuckerberg is seeing this as kind of an achievable goal, and that's that's why you hear this sentence being thrown around.
But concretely, what would superintelligence look like?
Well, okay, we already have a lot of AI systems that are better than us at many tasks, right? So you can buy a 30-euro gadget that plays chess and will beat you at chess, which means humans are not very good at playing chess. Similar for Go and poker, and there's a number of games like this where computers are just better than humans. But it's also true of, I don't know, solving equations, computing integrals in mathematics, or finding the best path in a map to go from one city to another, right? We're used to this. Like the machines are better than us at this. In fact, that's really what we should work on. Machines that are better than us at certain tasks for which we're not particularly good, right? That's the best way to assist humans with computers. That's actually the history of computers, really, using computers for things that humans are not particularly good at. So it's just a continuation of this, where in a future in which all of us will be walking around with smart glasses or other smart devices, within which there will be AI assistants that we can talk to, we can ask any question, maybe they display informations in the glasses and things like that, and that will sort of amplify your intelligence, if you want. It's like having a staff of really smart virtual people kind of working with you at all times. All of us will be like, a CEO or a minister or a university professor, with a staff of students who are smarter than themselves. So it's empowering. A lot of people kind of feel threatened by it. I think it's really empowering to work with people or machines that are smarter than you.
Can you talk a bit about the work you're doing at FAIR? Because the team has gone through quite a lot of changes recently, right? Joël Pinot, the VP of AI Research, left this spring, and there's been a lot of reorg. So how is your work going to change, and what do you need to do to get to that vision?
Well, so it's not changing particularly. Joël actually left just a few weeks ago. And the new person leading FAIR is Rob Fergus, who actually was one of my first hires at FAIR back 11 years ago. And then he spent 5 years at DeepMind and came back. So now he's leading FAIR, and it's basically an opportunity that we're seeing to sort of reboot FAIR towards the ambitious goal of AMI or ASI, and sort of plot a path for the more sort of product-oriented part of Meta to kind of follow, perhaps, to make progress towards human-level AI, essentially.
So
not that much of our organization, really.
Sorry?
there's not much of a reorganization other than a change of leadership, but other than that, our mission stays the same.
And so what would that concretely look like for a company like Meta? Is it products other than chatbots, or what?
Well, I mean, there's chatbots, right? We're used to them now. We want systems of this type that are agentic, so they can sort of, act in the digital world at least. We want perhaps systems that have a mental model of the user they're talking to, so they're not telling us things that we already know or that we're not able to absorb, right? So those systems will have to have some mental model of what we know, what we don't know, what we are capable of digesting, what kind of information we could be interested in. And systems that can, plan sequences of actions that might be complicated, making reservations for, travel and stuff like that. And then eventually also kind of similar things for the physical world. Domestic robots, robots of various types, and Meta is actually getting involved in robotics in sort of a big way. And then in between there are things like code writing, okay? So we have systems, I mean, it's probably one of the biggest applications of LLMs at the moment is helping software developers write code. And there is one issue with this, which is that very often when the code is produced, it's globally maybe correct, but not completely correct. You have to kind of fix some bugs and kind of change a few things. And those are generally relatively simple pieces of code, right? You can't ask a system to design a new algorithms or figure out a data structure for a particular problem that they've never seen before. They're basically kind of regurgitating code they've seen over the corpus that they've been trained on. What we want is, and that's what we're working on, a system that can imagine what the result of executing an instruction or making a function call will cause to the state of the program, and then plan a sequence of instructions to arrive at a particular goal. So it's very similar problem that I was talking about earlier, the ability to plan, to imagine what the consequences of your actions are. That's required for dialogue systems, for agentic systems, for code generation, and certainly for physical robots.
Yeah, if only humans can do that too. What's your vision for FAIR, right? Like, the AI field is so competitive and it's a constant talent war. How are you making Meta's AI research stand out and positioning yourself in the market?
Well, I think the plan that we are following for AMI, for Advanced Machine Intelligence, using those V-JEPA architectures and architectures that are capable of planning and reasoning, all that stuff, I think it's pretty original. I wrote sort of a vision paper that I published 3 years ago. I put online saying, like, here is where I think AI research should go over the next 10 years. This was before ChatGPT, right? And it hasn't changed significantly in the details, yes. And since in the last 5-6 years, we've been sort of making steady progress along this plan, basically. V-JEPA is just the latest incarnation of this. And so we're clearly making progress on those systems. Now, here's what's interesting. Those architectures, the V-JEPA architectures, are not generative architectures because they don't try to reconstruct or predict the world that they are trained on, the data that they are directly trained on. They are trying to learn an abstract representation, and they make prediction in that abstract representation space. So those architectures are not generative. Okay. Now, this is our long-term plan. This is what we are betting, quite a bit on at the research level. That doesn't mean that the current paradigm of LLM is not useful. There's obviously a lot of applications of LLMs that need to be developed, that are being developed. Foundation models that need to be open source. We're very big on open source at Meta, as you know. So it's not because you believe that reaching human-level intelligence requires a new paradigm like V-JEPA that you necessarily believe that LLMs are not useful. They're useful. We should be working on them. We are working on them. But it's a shorter term, and FAIR has always been kind of 3, 5, or 10 years ahead of the current fashion in AI. So that's still what we're working on. We have our eyes on the horizon.
And what sort of timeline are you looking at for superintelligence?
Yeah, that's a trick question, right? I mean, generations of AI researchers have been consistently wrong about this kind of estimate. So, okay, my story would be if all the planets lined up, if all the techniques that we are imagining developing work out, we're encountering the kind of usual difficulties in developing them and scaling them, we're going to have a good handle on whether this kind of V-JEPA approach is really going to take us there within 3 years. And then within 5 years, probably some early results or prototypes that may have systems that really understand the physical world, perhaps at the level of a cat or a rat or something like this, right? And then we're going to work our way up towards systems that can also plan not just in the sort of low-level physical world, but also in sort of abstract domains, perhaps connected with language or connected with mathematics or with geometry or things like that, right? And maybe reach human intelligence at some point, but it's almost certainly harder than we think. That doesn't mean we're not going to have useful, artifacts on the way to there. So I think we're going to start seeing kind of the more tangible applications of this maybe within 5 years or so.
Okay, and what do the next 6 months look like for Meta AI? The next 6 months.
Next 6 months. For us, we have like a plan of like so many problems to solve that we think we can solve, but we really need to work on them, right? So the V-JEPA V2 is one of the JEPA architectures. It's trained in a particular way on videos, and we can train them on, I think the amount of training we've done is like 1 million videos or something. It's a lot. So we can scale those models, we can scale the training. That's at least what we can demonstrate. We can show that we can use those models to plan simple actions for robots. Then we have to apply this to kind of more situations. But also, we don't think we have the perfect recipe yet. Like, we think there is probably a better way of training those JEPA architectures that we haven't figured out yet. So there's some work going on this. There are technical problems linked with planning. So when you plan a sequence of actions, and it's true for humans as well, we can't plan a very long sequence of actions. If it's a complicated task that requires many actions, we need to plan hierarchically. And this is a completely unsolved problem. So let's say I'm sitting in my office at NYU, and I want to be in Paris. I want to fly to Paris, right? So I cannot plan my entire trip to Paris in terms of millisecond and millisecond muscle control, which is really the low-level actions I can take. I have to plan this trip at a very abstract high level. And at high level, I can say, I need to go to the airport and catch a plane. And I don't need to know the details, I don't need to know how bad the traffic is or how I'm going to get to the airport, I just need to go to the airport. So now I have a sub-goal, going to the airport. I can plan a sequence of actions to get to the airport. I'm in New York, so I walk down on the street and hail a taxi. How do I walk down on the street? That's another sub-goal, where I need to get to the elevator, push the button, go down and walk out the building. How do I go to the elevator? I need to stand up from my chair, pick up my bag, open the door, walk to the elevator, avoid the obstacles and things like this. And it gets to a level where I have all the information I need to be able to take the action, right? So this idea that we're doing, everything we do, we plan hierarchically, is very powerful. We don't know how to do this with AI systems yet. We have some ideas, but it's still very much at the research level, and that's a big challenge to crack again for the next few years.
I know we're in time, but what is your intuition? How do we do that?
Well, we hire smart people. We, give them the problem, try to convince them that this is an interesting problem to work on, because most scientists and researchers have their own idea about what is a good idea to work on, so you can't really tell what to work on. You can do this with graduate students, though, so that's a good way to start. And then you try to kind of socialize this idea with other people so that they give you an idea about perhaps how to approach that problem. So the problem of planning, for example, there's a lot of very deep sort of questions that have to do with applied mathematics in there, not more than computer science, really. So you have to go talk to applied mathematicians and tell them, we have this problem that we don't know how to solve. It's an optimization problem. You guys have been working on this for 20 years, not necessarily for planning, but can you help us solve this problem? And it takes a whole scientific community, which is why it is very important to practice open research, because you need contribution. This is a scientific problem. It's not a technological development problem. You need to basically kind of gather all the talents that may contribute to this from the scientific community, in academia, in other companies, and public research, particularly in Europe. So that's why we need to practice open research. And then the outcome of this is that we open source our code. So V-JEPA v2 is open source.
That's a fantastic note to end on. Thank you so much, Yann. That was fascinating. And thank you so much for joining us today.
Thank you.
Around. Our next session will begin in 5 minutes.
Ouais, c'est bon la presse.